Wow, this has been a long unit. We're going to do some review. I'm going to get started right away because we have a lot to cover. First, we started in 5.1 with polygons, and we talked about the sum of the measures of the interior angles, n minus 2 times 180, or you could divide by n if you wanted one specific side. Remember that? The exterior angle sum theorem, they all add up to 360, so if you divide by n, it'll give you one exterior angle. These formulas work only for regular polygons. And then we went into 5.2 parallelograms. If you have a parallelogram, what are the characteristics of it? Opposite sides congruent, consecutive angles supplementary, opposite angles congruent, and the diagonals bisect each other. And then in 5.3 we talked about how you can prove that a certain quadrilateral or a given quadrilateral would be a parallelogram. Here's all the different ways you can do it. Remember, we add one, that if a pair of opposite sides is both congruent and parallel, then it is a parallelogram. Then we moved into special parallelograms, the rhombuses and the rectangles. So those are the next set of theorems we have. Remember, for a rhombus, the diagonals are perpendicular to each other and they bisect a pair of opposite angles. That's true for all rhombuses. And so you can work backwards. The converse is also true, and that's what the next two theorems are. Then we talked about rectangles. Remember, the diagonals are congruent to each other. So that's how you can tell if a parallelogram is a rectangle. And lastly, we ended with trapezoids and kites. Remember, for a kite, the diagonals are perpendicular. For a trapezoid, you have to know what a midsegment is. Remember, that's when you connect the midpoints of the legs. All right, that line is also parallel to the bases. That's one thing, and it is the average of those two bases. You add them up, divide by 2, and that's what the midsegment equals. We also learned about isosceles trapezoids. They have congruent base angles. They have congruent legs. All right, so that's the entire unit in a nutshell. Let's get back to some of these problems here, see if we can actually work some specifics out. Okay, so let's look at the first couple we have here. The first one is asking you to find the measure of one interior angle. All right, so we're going to use that corollary that says that if you take n minus 2 times 180, that will be the sum of all the different angles, but then you divide by n. So for number 1, you're going to get 6 minus 2 times 180 divided by 6. All of that should equal 120. Go ahead and work that one out, see how you do. A regular octagon. We don't need a picture. You can draw one if you want, but it should be 8 minus 2 times 180, all divided by 8. That should work out to 135 degrees. For these particular examples, where did my other thing go? Go away. What is going? I don't know. Okay, back here. All right, so find the measure. These are a different type of question. It says find the measure of one exterior angle. Make sure that you're paying attention here. So n equals 4 here. It's quadrilateral. It's a regular polygon. We know that it's a square. And actually, if you just use common sense, you extend a leg, this would equal 90 degrees. All right, so we should get 90 degrees. But the way you do it, you take 360. Remember, that's the sum of all the exterior angles. We have 4 of them. So in this case, it's 360 divided by 4, which is 90 degrees, which is what we thought using common sense. What about a 15-gon? Remember, a 15-gon means it has 15 sides, so that means it has 15 angles. So we divide by 15 here. You should get 24 degrees in one exterior angle for that one. All right, solve for x. Each is a parallelogram. Okay, now these angles here are consecutive. Remember, these are parallel lines. We have same side interior going on here. Here's a transversal. So they're supplementary. So 3x plus 10 plus 140 should equal 180 degrees. All right, so 3x equals, oops, don't equals, no equals. 3x plus 150 equals 180. Hey, 3x equals 30. X is going to equal 10. How fun was that? Here are opposite sides. The opposite sides are congruent, so x plus 3 equals 9. You better get 6 for that one. Those two are fairly easy. More parallelogram stuff. You have to be careful when they're talking about the diagonals, because some instances, like this one, they give you a half diagonal. And remember, they bisect each other, so that means this is exactly half from U to C. And then they give you the entire diagonal, which is 9x plus 3 in this case, which is UW. So the way you solve this, it takes 2 of these little ones to equal the long one. That's one way to do it. So 2 times UC, that should equal UW. All right, so how do we write that out? So 2 times 5x minus 1 will equal 9x plus 3. How do we solve it? A little distributive property. All right, if I subtract 9 from each side, you'll get an x over here. Add 2 to both sides, you'll get 5. X equals 5 here. But this says find UW. So if x equals 5, you got to plug it in. You get 45 plus 3. So UW equals 9 times 5 plus 3, which equals 48. Crazy! Let's look at number 8 here. Number 8, BF and FD. Well, they're giving you this, and they're giving you that segment, and they're equal to each other. So you can just set it equal. X plus 1 equals 2x minus 7. You get x equals 8. All right, done with that. Not done. Says find BF. BF is this. You got to be careful. They might ask you to find BD, but BF is the top part. They told you it's 2x. So BF equals 2x minus 7. So this would equal 2 times 8 minus 7, which is 16 minus 7. Hey, look at that. A fancy 9. How about that? We just did 8 problems super fast. Okay, number 9 is very similar to one we just did. Why don't you try doing that one by yourself? Make sure that YW equals 14. It's very similar to the one we just did. All right, 10 is a little different because we have angle 1 here, we have angle 2, and then angle 3 up here. And if you notice, we have a parallelogram. All right, it told us it was a parallelogram. If you don't believe me, it was. And so consecutive angles are supplementary. So that means angle E, which is 3, is supplementary to angle EFG, that entire angle. Well, you can see this angle is divided into 2 parts. So what you need to do is take these 2 parts, add them together. That plus angle E, that's up here, 5x plus 15, all of that should be equal to 180 because this angle and this angle are supplementary. So, how do we do that? 56 plus 8x plus 5 plus 5x plus 15 should all equal 180 degrees. All right, how are we going to do this? 13x. That'll get those x's together. Then what do we got? 20, 76 plus 76 will equal 180 degrees. Take away 70 and I get 110. Take away 6 more and I get 104. That's 13x. All right, equals 104. What are we looking at? 8 here. X equals 8. And then if I plug it into, they want EFG. That's the entire angle. So that would be 56 plus 8 times 8 plus 5. All right, because I'm plugging an 8 in here. So that'll give us 64 plus 5 is 69 plus 56. And what are we looking at? 5, carry the 1, and we get 125. So that's the answer to 10. All right, then we go into trapezoids. Now, if you look, these little signs right here mean that this trapezoid is isosceles. The base angles are congruent. The diagonals are congruent. So here we have one set of diagonals here. We can just set it equal to each other. What do you do? Add that, get 40, x equals 10. They want you to solve for x, so you're done right there. Please make sure you're solving for what they're asking for. Here is a trapezoid. It says it's a trapezoid, so that means that these, I'm assuming, are the base sides. All right, these are the bases. And so what we have here, parallel line, transversal going through it. These are same side interior, so that means that we have supplementary angles here. So 6x minus 8 plus 122 equals 180. If you go through all of that and you solve it, you're going to get x equals 11. All right, there's 12. We are burning through this chapter. Next one, midsegments. Awesome. Remember, the middle one is the average of the bases. The midsegment is the average of the other two. So if I add up the other two, so 6x minus 8 plus 3x minus 14, and I divide by 2, I get the midsegment, negative 5 plus 4x. All right, so now we have a little combining of the like terms to go on. So 6x and 3x is 9x. We got negative 8 and a negative 14. That's minus 22 all over 2. That'll equal negative 5 plus 4x. Remember, we throw that over 1 and we cross multiply now. So 1 times 9x minus 22 is just 9x minus 22. Then we get 2 times negative 5 plus 4x. All right, why am I writing uphill? Nobody knows. Distribute. This equals negative 10 plus 8x. We get 9x minus 22. This is actually easier than you thought to solve because you subtract 8x. You get more room on the page. Hope you got a long piece of paper. That was ugly. Hope you got a long piece of paper. And what do we get? X minus 22 equals negative 10. Add 22 to both sides. X is 12. What's it want us to do? Are we done? Please tell us we're done. Find the length of the midsegment. Oh, man. So the length of the midsegment is negative 5 plus 4x. So negative 5 plus 4x. That is the midsegment, which is negative 5 plus 4 times 12. Negative 5 plus 48, which is 43. Oh my goodness, the length of the midsegment is 43. Please circle it so everybody knows what your answer is. Okay, 14. Let's get rid of all this stuff. That was crazy. RT and QS. These are diagonals. It's isosceles, so you can set them equal to each other. So negative 19 plus 3x is going to be equal to x minus 1. Subtract x from each side. You get 2x equals. Add 19 to both sides. You're going to get 18. X is 9. Find RT. Plug a 9 in. You get 27 here. And negative 19 plus 27. What's that all equal? 8. All right, so RT equals 8. I know I'm going fast, but we have so much stuff in this chapter. Looking at 15 and 16. Whoo, this is a kite. Look at that. If this is x, then this is x. Right? You know why? Because look. Isosceles triangle. Those are congruent. Base angles are congruent. So 2x plus 20 plus x plus x. That should all equal 180 because it's the sum of the angles of a triangle. So what do we get here? 4x plus 20 equals 180. If I subtract 20 from each side, I'm going to get 4x equals 160 or x equals 40. That was easy. It says solve for x, so I'm all done with that one. I'm on fire. Let's do the next one. Find 1, 2, and 3. All right, well, 2 is the easy one. 2 is 90 degrees because this is a kite, and the diagonals of a kite are perpendicular. Now what else? Remember I told you that line going down the middle of the kite? Okay, that bisects these angles, so that's going to make life a little bit easy. 1 is not congruent to 3, but 3 is congruent to this guy over there, so 3 is going to be the same as 66 degrees. Now what? Well, I'm looking at this triangle right here. Oh, can't draw a triangle. So this is isosceles again. They're the two legs that are congruent. So that means this side has to be 75. And this entire angle is going to be, if you take the entire angle, let's call it x. So x plus 75 plus another 75 should equal 180. So this 75 plus 75 is just 150. All right, 180. X equals 30. But remember, that's the entire angle. We need half of it. So we're going to get 15 for this one. Whoo! That was fun stuff. Let's look at 17. Here's our substitution problems and our factoring problem. It's going to happen. It's going to be on the test. So let's look at it. 17. This is a parallelogram, so opposite sides are equal. So you get y equal to 3x minus 7. You also get 6y is equal to 3x plus 18. Voila! Look, if y equals 3x minus 7, then down here where I have the y, I can put 3x minus 7. That will be equal to 3x plus 18. Oh my goodness, more distributive property. We love distributive property. Algebros are loving it. We love you to distribute. It's one of our favorite things. Why am I writing uphill? 18x minus 3x. I'm going to subtract 3x on each side. All right, so what do we get? 15x minus 42 equals 18. If I add 42 to each side, I'm going to get 60, or x is going to equal 4. What's y equal to? Plug a 4 in here, you get 12 minus 7, which is 5. So y equals 5. Everybody follow that one? You get 4 and 5. That is amazing. I love that problem. It's my favorite problem. Let's go to 18. 18 involves, what do we got? Diagonals. You know they bisect each other. So 9k is going to be equal to k squared plus 18. Quadratic equation, bells and whistles go off. You got to set it equal to 0. So we subtract 9k from each side. We get 0 equal to k squared minus 9k. Remember, I'm putting it in standard form. You got to write the k squared first and then the k. That's why I kind of snuck that in the middle there. You cannot combine like terms because these are all different terms. One is a squared, one is a regular k, and one is just a number by itself. So now comes the magic x. All right, 18 goes in the bottom, and then a negative 9 in the top. I'm thinking 6 and 3, they both have to be negative if they're going to add to negative 9 and give you a positive 18. So we get k, ooh, almost went x there, k minus 6 times k minus 3. All of that's got to equal 0. Remember our zero product property? We can now set each one of these up equal to 0. Sully taught us this. Thanks, Sully. You're so cool. All right, so we k equals 6 and k equals 3. You need both of those with a big fat or in the middle. Now we're looking at, oh, these are easy. You can do these. Look, this is a rectangle. These are bisected. You know the diagonals of a rectangle are congruent, so if you cut them in half and bisect them, they should be congruent. You set these equal to each other. I mean, we can almost solve that in our head, get x equals 30. 10, or 12, sorry, 20. Holy moly, it's been a long video. What is the value of x? Remember, this is a rhombus. They want it to be a rhombus, so that means this has to be 90 degrees. So our equation is 2x plus 65 plus 4x minus 25 plus a 90 has to equal 180 degrees because I'm looking at this triangle right here. Okay, all of these angles, when you add them, equal 180 degrees. Let's add it up. Combine like terms. 6x, 65 minus 25 is 40 plus 90 is 130 equals 180. All right. This problem is an application wonder. I love these coordinate proofs. Basically, you have to plot points and use the slope formula, distance formula, and all that kind of fancy stuff. All right, let's look at this. Part A, graph and label brus. Man, that's almost ugly. That's almost brust. All right, the coordinates are B, negative 8, 1. So what you need to do, negative 8, 1. So this is B, graph and label, negative 8, 1. R, 0, 0. All right, so we're going to put an R there and call it 0, 0. U, negative 1, negative 5. So that's down here. U, negative 1, negative 5. And lastly, S, negative 9, negative 4. So that's right here. S, negative 9, negative 4. So now we've graphed this. I'm going to use my straight line tool here and see how we can do connecting this. It says it's a quadrilateral. So we're going to go in order, B-R-U-S, and there you go. So does it look like anything? Is it a rectangle? I don't know. Is it a parallelogram? Maybe. So that's the whole point of these questions. What you have to do is, it says part B, use the slope formula to determine if brus is a parallelogram. So let's find the slope of SB first. So the slope, which we use an M, of SB is equal to, all right, so here's how we do slope. 1 minus negative 4. Minus negative 4. Negative 8 minus negative 9. Negative 8 minus negative 9. What does all this equal? This equals 5 over 1, positive 1. You better make sure you got your integers right. Okay, so that is the slope of SB. Let's look at the slope of UR. Slope of UR. That's going to equal, let's go this way, 0 minus negative 5 over 0 minus negative 1. All right, that equals 5 over 1. Look, oh, look, I can point to these two, and I can say SB is parallel to UR. What's the reason why? The reason why is because they have the same slope. All right, now you have to do the other two. All right, so you have to do all four. We did these two. We did that one and that one. We found out they're parallel. Ta-da! Everybody's happy. Now do the other two. See if they're parallel. I think you'll find out they will be parallel. Next part of the question. They could ask you to examine your answer to part B to determine if it's a rectangle. How would you know? Well, look, rectangle needs a right angle. Is this a right angle? I don't know. Look at this line segment, the slope of it. We already know that. We just figured that out to be 5. Okay, now look at this line segment. Remember, you need a negative reciprocal, so it needs to be negative 1 over 5. If that's what you get, then that's a right angle. If you don't get negative 1 over 5 for the other ones, it's not a right angle, therefore it's not a rectangle. That's how you know that. Use the distance formula to determine whether brusts, I don't even know how to say that, diagonal are congruent. Remember, diagonals go across the middle, so you're going to use the distance formula on SR and B, what is that, U, okay? And here's the thing, if it's a rectangle, which we know it isn't, oh, did I let the cat out of the bag? It's not a rectangle. But if it's a rectangle, then the distances will be the same. But when you use the distance formula, you're going to get two different distances. Therefore, it's not a rectangle. All right, part or number 2 here. Draw rhombus ROM with diagonals. Hold on a second. Remember, you got to go around in order. So let me draw a rhombus. Let me see. Try to think. I know what I'm doing here. So R, H, O, M. Okay, you can start anywhere, but you got to go around the circle. All right, with diagonals RO and MH. Oh, I was doing so well to that one. Find X if HMO, that's this angle right here, is 44. And if the measure of angle HMR is 4x plus 4. All right, well, we know that in a rhombus, the opposite angles are bisected. So basically, the bisect, they're congruent to each other. You can set it equal. 44 equals 4x plus 4. Do you get x equals 10 for that? Booyah. Let's do the last two. Okay, and the last thing I'm going to go over is a proof. Oh, this one looks kind of ugly here, but I'm just basically going to talk you through it. I'm not going to give you every single step here, but you can write the given down. All right, and remember, this means it's a perpendicular, or it's a parallelogram. Parallelogram. My video is getting long. I got to hurry up. This is a parallelogram. So, what do we know about parallelograms? We know the opposite angles are congruent. We know the opposite sides are congruent. What else do we have here? Probably vertical angles we're going to use here one way or another. So what do we have? Given. So we write the given. So we have parallelogram lens and length. All right. And the reason why it's given. All right. So what else? What do we want to prove? That S is supplementary to T. So the way we're going to go about this, here's S right here. So we want to prove that that's supplementary to T. Well, I know S is supplementary to this angle right here. I'll call it angle 1. All right, so if S is supplementary to 1, 1 is going to be congruent to 2. Okay, T is congruent to 2. All right, so then T is kind of congruent to 1. So then S is going to have to be supplementary to T. Everybody follow that? Look, 1 is congruent to 2 and 2 is congruent to T. So 1 is congruent to T. And if S is supplementary to 1, then S has to be supplementary to T. Got it? That's how the proof goes. You're going to have to write it up and try to figure that out. And look, check the answer sheets. You know, that's a pretty good one. This is actually on the review, I believe. Or is this the corrective sign? I don't know. Where did I get this problem? But a proof like this could be on the test. So, that's all she wrote. This is way too long, this video. I got to get out of here. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. See you.